Alright, hello math people. Let's start with our practice check from today. I asked you to consider some recipes because we were looking at recipes for juices on Thursday, and I want to know which of these recipes are going to taste the same and which of these taste different. So if you look at this, you've got your three recipes, and we've got a ratio for each of them. Our ratio for recipe 1 is 4 to 6. I can reduce that ratio and say that it's like the same as 2 cups of orange juice to 3 cups of pineapple juice. Recipe 2 is 6 cups of orange juice to 9, or 6 to 9. I can reduce that by dividing both by 3, and I also get 2 to 3. Ooh, equivalent ratios. That's a good sign that they're going to be the same. I just scaled recipe 2 up. Now recipe 3, 9 cups of orange juice to 12 cups of pineapple juice. If I reduce both of those by dividing by 3, I'm going to get 3 to 4, so that is not the same ratio. Recipe 1 and recipe 2 are actually going to taste the same. They'll have the same kind of combination of oranginess and pineapple-iness, and recipe 3 is going to be stronger in one way than in the other. So then we started looking at tables and thinking about how a table can be a useful way to arrange data. I asked you, what did you notice and what did you wonder here? And a lot of people started noticing that there was something going on across the table. If we were ordering one case, then we would need 12 paper towels. Well, 1 times 12 is 12. If we were ordering 3 cases, that would get us 36 paper towels. 3 times 12 is 36. 5 times 12 is 60. 10 times 12 is 120. So even though the way that the table was set up and was encouraging you to look at the times 2 down the table, most of you were starting to notice that there was something going on across the table. And that seems like that might be a useful way to think about these kinds of relationships as well, not just scaling up and down. So now I gave you a table that wasn't completely filled in. I said that I host waffle parties, and I use Bisquick, which is this big floury-like thing that I can get from Costco, and I just add in some liquids and I now have waffle batter. It's really great if you're having big waffle parties. I know that 2 cups of Bisquick are going to serve 6 people, so I'd like to fill in this table with the rest of the information here. Since we had been looking across the table with the notice and wondering, a lot of people started going there as well. They noticed that 2 times 3 would give us 6. 3 times 3 would give us 9. So there's something that's the same in relationships like these, where the ratio is staying the same. So then let's do 10 times 3. That means we can serve 30 people. And something times 3 is going to serve 45 people. And that would be 15 times 3. And we had students that were noticing that you could divide 45 by 3, the inverse operation, and get that that would be 15 cups of Bisquick. So then I said, what if you wanted to get down to 1 cup? What could 1 cup serve? Well, 1 times 3 is 3. And this is what we call a unit rate. A unit rate is a ratio where you have 1 of something. In this case, 1 cup of Bisquick. What is it that we can handle if we have 1 of something? So whenever we have a situation like this, where 2 quantities are always in the same ratio, this is called a proportional relationship between those quantities. The relationship here that is proportional is the number of cups of Bisquick to the number of people. We would say that the number of cups of Bisquick is proportional to the number of people. And I said that word a lot because I know that proportional is a new word, but it means you have the same ratio. Always have the same ratio. So now let's apply this to the orange juice. People were noticing pretty quickly that if we're going to from 6 to 3, that would be like dividing by 2 or multiplying by a half, taking half of the left-hand side. So half of 30 would be 15, half of 40 would be 20, and half of something would be 28. Some folks considered that inverse operation, going from the right to the left, and said times 2, and they got 56. Half of 56 would be 28. So this relationship holds throughout the table. So then I asked, what's the unit rate here? How do we get to 1 of something? Going from 6 oranges to 1 orange, I could do 6 divided by 6 is 1. So then on the other side, I would need to do 3 divided by 6. We would be scaling it down by 6, and I would get 1/2 So 1 orange would feed half a person. That would be one way we could write that unit rate. A little bit weird because you cannot actually have half a person. But you see, as we scale it up, you end up with whole numbers of people, which makes a lot more sense. You could also, though, look at 1 person. So if we wanted to get to 1 person, we could take 3 people and scale that down, divide by 3 to get 1. Then we would need to divide oranges 6 by 3 as well, and we would get that 2 oranges would feed a person, which 2, half of 2 is 1. So that works. The unit rate, 2 oranges to 1 person would hold. And I've underlined 1 orange and 1 person because 1 is what matters here. We got to a unit of 1. Here, people really wanted to multiply across. But they looked at this and they got stuck. And I loved that they were getting stuck here because this showed they were wanting to apply strategies that they'd developed, and they were finding that there was something that made this a little bit more challenging. So they needed to think about what new information from today could we use. So we want to multiply across, but 8 cannot be multiplied by a whole number to get 10. So it wasn't going to be a simple multiplication across. Then let's find a unit rate. If we want to find the unit rate here, 8 divided by 8 would get me to 1 teaspoon of honey. On the flour side then, I need to scale down by the same thing. We divided by 8, so 10 divided by 8 would be 1.25. 1.25 is my unit rate. Well, 1 to 1.25, I would be multiplying by 1.25. So if I do 20 times 1.25, that would be 25. 13 times 1.25 is 16.25. And something times 1.25 is 20, which people said inversely you could do 20 divided by 1.25 is 16. In this relationship, we would say that the amount of honey is proportional to the amount of flour needed. This 1.25 that you got by scaling it down to the unit rate, this has another name. Its name would be the constant of proportionality. It is the constant multiplier in the relationship. That means that it does not change. In every row, you multiply everything on the left, honey, by 1.25 to get to everything on the right, flour. So in this relationship, 1.25 is the constant proportionality to get from honey to flour. Looking at our first homework problem, we have quarters and dimes. People noticed that, if I want to multiply across, again, 4 to 10 is not going to be a whole number. So what would be my constant of proportionality here? My question for you is, how can you calculate a unit rate here? And how could you use that to find your constant of proportion? Well, how could you use that to find the rest of the values in your table? Have a great night. Check in with me if you have questions, and we will look at this more on Thursday.